Hey there folks, Slam and Sammy Systems here talking to you about solving linear inequalities. Now I got a question. Where do baseball players have to go when they ruin their uniform? New Jersey! Bing!
The first vocabulary term is an inequality, and that's when two statements are not equal. So you're going to have two expressions, and instead of having an equal sign in between them, you're going to have one of these symbols, and that's going to tell you which expression is less than, greater than, less than or equal to, or greater than or equal to the other one. And remember, when you're graphing these, less than and greater than are just going to be the open circles, whereas the less than or equal to and the greater than or equal to will be the closed circles. Remember, that's the key, is just look for this equal sign underneath, and if there is an equal sign underneath, you're going to shade in that circle.
Why didn't the geometry teacher like the shape of a baseball? 'Cause it's pointless! Boom! Example time!
Okay, example 1 says determine whether the ordered pair is a solution to the linear inequality. So here we have our linear inequality and we have our ordered pair. So how do we determine if this is a solution? Well, we're going to take -1, we're going to plug it in for x, and we're going to take 3 and plug it in for y and see if the inequality comes out true when we simplify it. So let's do that. We're going to plug in our points. So we take -1, plug it in for x, take 3, plug it in for y. Now what's 3 times -1? That's going to be -3. And what's -3 plus 4? That would be 1. Now, is this inequality true? Is 3 greater than 1? Yes, it is. Because it's true, you know that this point is one of the solutions to this linear inequality. Next, for part B, we're doing the same thing. We have x is less than 5, and we have the point 6, 4. So we want to determine, is this point one of the solutions to this inequality? Well, all we have to do is plug in the point and simplify and see if the inequality comes out true. So what we're going to do is we're going to take this inequality and we're going to plug in, oh, there's no y, there's only an x. Well, that's okay. We just plug in the x value. So what's our x value? That's 6 for this point. So we take 6 and plug it in for our x value. And is this true? Is 6 less than 5? No, it is not. Therefore, this point is not a solution to this linear inequality.
What's a baseball player's favorite thing about the park? The swings! You try!
Okay, doing the same thing here. Again, we want to take this point and plug it into this linear inequality to see if it comes out true when we simplify it. So we're going to take 3, plug it in for x. We're going to take 0 and plug it in for y. Now we simplify. What is -2/3 times 3? Well, remember, 3 is the same thing as 3 over 1. And when you multiply fractions together, you multiply the numerators together and denominators together. So it looks something like this. Now what is -6 over 3? That becomes -2. So what is -2 plus 3 then? That would be 1. So now we get to our point where we decide, is this inequality true? Is 0 greater than or equal to 1? No, it is not. Therefore, this point, 3, 0, is not a solution to this particular linear inequality. Over here, we have 3y is greater than 5x minus 12. Now, is it okay that this is not in slope-intercept form, y equals mx plus b? Yeah, that's fine. All we have to do is just plug in our point and see if the inequality comes out true. So we take 1, plug it in for x, and we take -2 and plug it in for y. Now we simplify. What is 3 times -2? That's -6. What's 5 times 1? That's 5. Now what is 5 minus 12? That gives you -7. Then you decide, is -6 greater than -7? Yes, it is. It's more positive, so it is greater. Therefore, 1, -2 is a solution to this linear inequality. Now let's talk about graphing linear inequalities. So the first thing you want to do when you're graphing a linear inequality is get the inequality into slope-intercept form, y equals mx plus b. Now in this case it's going to be a linear inequality, meaning that it's not going to be an equal sign in here, it's going to be an inequality symbol, but that's okay. Next, we're going to plot 3 points using the y-intercept and the slope. So we're going to plot the y-intercept and use the slope to get the other 2 points. Then you're going to choose whether the line is going to be solid or dashed. And all you have to do is look at the inequality symbol. If there's an equal sign underneath your inequality sign, it's going to be a solid line that you draw. If there's no equal sign, then you're going to have a dashed line that you draw through your 3 points. Then you have to decide, are you going to shade above your line or below your line? And that just depends. Is it y is greater than or y is greater than or equal to? Then you're going to shade above. Is it y is less than or y is less than or equal to? Then you're going to shade below. If you can't remember that, then you just think, is your inequality symbol eating your y? If it's eating your y, you shade above. If it's facing away from your y, you shade below. And it says to determine shading, you can always choose a test point. It's exactly what we were just doing in example 1. If you pick a point on one side of the line and plug it in, you simplify and see, is that point part of the solution set to your inequality? If it comes out that the inequality is true, then you just shade on whatever side you picked your test point on. If it's not true, then you shade on the opposite side. So let's check this out. Now, example 2 says graph the solution to the linear inequality. So we have y is less than or equal to negative 2x plus 4. So the first thing we want to do with our linear inequality is make sure it's in slope-intercept form. So we have y is less than or equal to negative 2x plus 4. We have y, we have mx plus b. Perfect. We are in slope-intercept form. Next, we want to plot 3 points. When we plot 3 points, we want to start with our y-intercept. So b is our y-intercept. So at 0, 4, we are going to put a closed circle. Now, the reason it's a closed circle is because we have an equal sign here. And then when we plot 3 points, our first is our y-intercept, and our other 2 we get from the slope. So what's our slope? Negative 2. How do I write that as a fraction? Negative 2 over 1. So I go down 2, right 1, put a point. Down 2, right 1, put a point. Next, I want to determine, is it going to be a solid or a dashed line that I draw through these 3 points? Well, again, because there's an equal sign underneath my inequality, I'm going to draw a solid line going through these 3 points. This means that any point on this line will make this inequality true. Next, do I shade above or below this line? Well, since my inequality symbol is facing away from my y, that means I want all y's less than this given line. So I want to shade below this given line. So it's going to look something like this. Now, what does this mean? This means that any point in this shaded region and on this line, because there's an equal sign, would make this inequality true. So again, if you weren't sure which way to shade, you can always pick a test point. If I were to pick 0, 0 and plug it in, 0 for y, 0 for x, and simplify, I would end up getting 0 is less than or equal to 4. Is that true? Yes, 0 is less than or equal to 4. Therefore, that's why I shade on this side of the line.
What do frogs make such good outfielders? 'Cause they never miss a fly. Boom! You try.
Okay, doing the same thing. First, put it in slope-intercept form. Y, and then we have mx plus b. Yeah, we're already in slope-intercept form. Perfect. Next, plot 3 points. We start with our y-intercept, which in this case, our b value is negative 2. So we go to our y-axis, we go down to 0, negative 2, and we're going to put a solid point, a shaded point, because there is an equal sign here. From there, what is our slope? It's 1. We write that as a fraction 1 over 1. So from our point, we go up 1, right 1, put a point. Up 1, right 1, put a point. Sweet, we have our 3 points. Then we decide, are we going to draw a solid or a dashed line? Well, because there is an equal sign underneath the inequality symbol, we are going to draw a solid line going through those 3 points. That's also why we shaded each of these points in. We didn't have open circles. Next, are we going to shade above or below this line? Well, because our inequality symbol is eating the y, it's y is greater than or equal to. We want all y's greater than or equal to. We're going to shade above this given line. So it's going to look something like this. Now, again, you can always pick a test point. If I pick 0, 0 and plug it in here, I get 0 is greater than or equal to 0 minus 2 or negative 2. Is that true? Yes, that's why we shaded on this side of the line. And again, what this means, this shaded region, this is every point that will cause this inequality to be true. If I plugged in any point in this region or on this line, because there's an equal sign, it would cause this inequality to come out true. Now, example 3, doing the same thing. Here, first, we want to put it in slope-intercept form. This time, it's not already in slope-intercept form. We have this negative 2 times our y. We got to get y by itself. How do we do that? Well, to get rid of this y, to move it to the other side, we're going to divide both sides by negative 2. And when we divide both sides by negative 2, over here, we divide each term by negative 2. That way, these cancel each other out. And then over here, negative 4 divided by negative 2 gives you positive 2. And negative 6 divided by negative 2 gives you positive 3. Now, here's the question. Are we going to have to flip the sign? Yes. Remember, anytime you have an inequality and you divide both sides or multiply both sides by a negative number, you must flip your inequality sign. This is our new linear inequality. It's in slope-intercept form. Perfect. So we can move to step 2, which is to plot our 3 points. We start with our y-intercept, which is 3. So we go to 0, 3. Notice there is no equal sign under here, which means that every point on our line is not part of our solution. So when we plot these 3 points, we're going to put open circles because this denotes that our line is not part of our solution. So we have 1 point. How do we get our other 2 points? Well, we use our slope. What's our slope? 2. We write that as a fraction 2 over 1. So from this point, we go up 2, right 1, put an open circle, up 2, right 1, put an open circle. We have our 3 points. Now we need to decide, are we going to have a solid or a dashed line? Again, because there's no equal sign here, we have to use a dashed line. This indicates that the points on this line are not a solution to this inequality. Then we decide, are we going to shade above or below this line? Above or below? Well, since our inequality symbol is facing away from our y, we want all y's less than 2x plus 3, so we want to shade below this given line. Looks something like this. This indicates that every point in this shaded region would make this inequality true, just not any point on the given line.
Why are some umpires overweight? Because they always clean their plate. Boom, you try.
Okay, doing the same thing here. First, we want to put it into slope-intercept form, y equals mx plus b. So the only thing we need to get rid of is this little negative sign right here. So we're going to divide both sides by -1. Now when we divide by -1, the negatives cancel each other out over here. X divided by -1 becomes -x, and 1 divided by -1 becomes -1. And don't forget, when you divide or multiply both sides by a negative number in an inequality, you need to flip your sign. Now we have our linear inequality in slope-intercept form, so we're ready to plot our 3 points. We start with our y-intercept, which in this case is -1. So we go over to our y-axis, and at 0, -1, we're going to put a closed circle because there's an equal sign here, meaning that our line is going to be included. Then we get our 2 other points by using our slope. What's our slope? -1. In order to write that as a fraction, that's -1 over 1. So we go down 1, right 1, put a point. Down 1, right 1, put a point. Next, are we going to have a solid or a dashed line? Well, it's easy because you decided to have closed points, meaning that there's an equal sign under here, meaning that we are going to have a solid line. So we draw a solid line going through those 3 points because we have a little equal sign under our inequality symbol. Next, we need to decide, are we shading above or below this line? Well, the inequality symbol is facing away from our y value, meaning that we want all y values less than or equal to -x minus 1. So less than means below. We're going to shade below the line. This means that every point in this region, including points on this line, will make this inequality true. Example 4, doing the exact same thing. First, we want to put it in slope-intercept form, y equals mx plus b. So we got to get y by itself. We start with anything added or subtracted to our variable. So this x has to get over here. To move this to the other side, it's positive x, so I subtract x from both sides. Here, these are going to cancel each other out. And on this side, instead of writing 9 minus x, I want to put it in slope-intercept form. So I'm going to put the x first. So it's going to be -x plus 9. Next, to get y all by itself, I got to get rid of this 3. So since it's 3 times y, I divide everything by 3. That way these cancel each other out. This becomes -1/3 x, and this becomes 3. So we have our slope-intercept form of our given linear inequality. Next, we are ready to plot our 3 points. So we start with our y-intercept. What's our y-intercept? That would be 3. So we go to 0, 3, and we put a point. We put a closed circle because, again, there's an equal sign here, meaning that when we decide whether we have a solid or dashed line, it's going to be a solid line. From here, we are going to use our slope to get the rest of the line. So since it's -1/3, that means we go down 1, right 3, put a point. Down 1, right 3, put a point. Then we decide, are we going to have a solid or a dashed line? Because there's an equal sign here, and we used closed points, we're going to use a solid line. Next, are we going to shade above or below this line? Well, since our inequality symbol is facing away from our given y value, we want all y values less than or equal to -1/3 x plus 3. We want all the y values below this given line. That means that any point in this region and on this line would cause this inequality to come out true.
Why are singers so good on the mound? Because they have perfect pitch. Boom, you try.
Okay, doing the same thing here. First, we want to get it into slope-intercept form, y equals mx plus b. So to get y by itself, the first thing we're going to move is this 3x. How do I get that to the other side? Since it's positive 3x, I subtract 3x from both sides. That way these cancel each other out, and I get 2y is greater than. Now I could write 1 minus 3x, but I want it in slope-intercept form, mx plus b. So I'm going to put this term first, negative 3x, and then add the 1 to it. Now it's looking more like slope-intercept form. So to get y all by itself, I divide both sides by 2. When I do that, I make sure to divide each of these terms by 2. These are going to cancel each other out, and I get y is greater than negative 3 halves x plus 1 half. We are in slope-intercept form. Next, we're going to plot 3 points. Again, there's no equal sign underneath, which means when we plot our points, they're going to be open circles to show that those are not solutions to this given inequality. What we can do is we can start with our y-intercept, right? Our y-intercept is 1 half. So we go to our y-axis at 0, 1 half. We're going to put an open circle. Then we're going to use our slope to get the rest of our 3 points. So from our given open circle, our y-intercept, we're going to go down 3, right 2. So we go down 1, 2, 3, right 1, 2, put an open circle. Down 1, 2, 3, right 1, 2, put an open circle. Sweet, we got our 3 points. Now is this a solid or a dashed line? Well, again, because we're using open circles, that means that there's no equal sign underneath. That means that it's a dashed line that we're going to be drawing through these open circles. Next, are we going to shade above or below this given line? Well, since our inequality symbol is eating our y, that means we want all y's greater than negative 3 halves x plus 1 half. We're going to shade above this given line. So it's going to look something like this. Again, every point in this region would make this inequality true if you were to plug it in, except the ones on the line. That's why it's dashed. That's why we did open circles. Now, example 5 says write the inequality for the given graph. So this time we're given the graph and we want to write the inequality. First thing you want to do is find the equation of the line. What is the equation of this line? Well, in order to find the equation of the line, we need the y-intercept and the slope. So what is the y-intercept? Where does this graph cross the y-axis? That would be at 6. So our b value in this case is going to be 6. Then what is the slope? Well, the slope is just rise over run. So what are some points on the line besides this y-intercept? It looks like here we have a point and here we have a point. So our slope looks like we are going down 1, right 3. Down 1, right 3. So our rise would be negative 1. Our run would be 3. So our slope is negative 1/3 and our y-intercept is 6. Therefore, if we were to put this in y equals mx plus b form, it would look like this. Y is equal to negative 1/3 x plus 6, where negative 1/3 is our slope and 6 is our y-intercept. Now the question is, what is the inequality that goes in here? Well, first, is it a solid or a dashed line? It's a solid line, right? Therefore, there's going to be an equal sign under our inequality. Then we have to decide, is it eating the y or facing away from the y? Is it greater than or equal to or less than or equal to? Well, because we are shading below the given line, the inequality should be facing away from the y. It should be y is less than or equal to negative 1/3 x plus 6. And you're done.
Why did the high school ask the tiny goats to play on the baseball team? Because they needed a little team spirit. Boom, you try.
Okay, again, we are given the graph and we want the inequality. So first, we're going to find the equation of this dashed line. We start by finding the slope and the y-intercept. What's the y-intercept? Well, that's where the graph crosses the y-axis. That would be right here at negative 1. So our b value is negative 1. Now, what's our slope? Our rise over run. Well, from this point, it looks like we're going up 2, right 1 to put a point there. Up 2, right 1 to put a point there. Therefore, the rise over run would be 2 over 1 or 2. So if we were to put this in y equals mx plus b form, that's y equals 2x minus 1. Now that we have our equation, we can then figure out what our inequality symbol in here is going to be. So first, is it a solid or a dashed line? Clearly a dashed line. Therefore, there's going to be no equal sign under your inequality symbol. Next, did we shade above or below the given line? Well, it's shaded above. Therefore, it should be y is greater than the 2x minus 1. So we write our inequality like that, and you're done. Again, if you wanted to, you could pick any point in the shaded region, plug it in to see if you got it correct. Okay, example 6, doing the same thing. We want to write the inequality for this given graph. So first, what's the equation of this green line? Well, it's a horizontal line, if you recall. So we don't have to do the y-intercept and the slope. It's a horizontal line, which means the equation of the line is just y equals a number. And the number just depends on where does it cross the y-axis. It's at -1. That means that the y-coordinate for each of these points is equal to -1. So the equation of the line is y equals -1. Now we decide in this graph, do we have a solid or a dashed line? It's clearly a solid line. And did the graph shade above or below? Obviously below. So what this means is we're going to take this equation, and since it's a solid line, there's going to be an equal sign under your inequality. And since we shaded below, the inequality symbol is going to be facing away from the y. It's going to be y is less than or equal to -1. And again, you could pick any point on this shaded region, plug it in here, and you should get that it comes out true, right? If I picked 0, -4, plug in 0 for x, there is no x. I plug in -4 for y, yes, -4 is less than or equal to -1.
What's harder to catch the faster you run? Your breath! Boom! You try!
Okay, doing the same thing here. First, write the equation of the line. This line right here, this vertical line. The equation of a vertical line is x equals a number. So what x coordinate do all of these points have in common? 5. So x equals 5 is the equation of this vertical line. Next, is it a solid or dashed line? Clearly a dashed line, meaning that there's no equal sign underneath our inequality symbol. And now, our next question is usually, do we shade above or below? But since it's a vertical line, there is no above or below. There's just a left or a right. So, do we shade to the right or the left? Well, it's obviously shaded to the left of your vertical line. Left is the same as below with what we were doing before. So, since we shaded left, that means our inequality symbol is going to be less than. It's going to be facing away from our x. And since it's a dashed line, there's going to be no equal sign. So, it's just x is less than 5. And again, every point over here makes this inequality true if you were to plug it in. Okay, now our word problem says the supermarket charges $9 per pound for New York strip steak and $12 per pound for a ribeye. Write an inequality that shows how much of each type of steak you can buy with the $120 you brought to the store. Graph the inequality and name 3 possible amounts of steak you can purchase. So, step 1, in a word problem. We're not scared. We can do this. Step 2, what is it asking us to find? It's asking us to write an inequality that shows how much of each type of steak you can buy. From there, we're going to graph the inequality and name 3 possible amounts. But we need to take care of this first. So we're going to write an inequality that shows how much of each type of steak we can buy. Move to step 3, which is define our variables. So what are our variables here? Well, it's $9 per pound for New York strip steak and $12 per pound for a ribeye. That means that the pounds of New York strip steak and the pounds of ribeyes should be our variables if we're multiplying them by 9 and 12 respectively. So we'll say S is going to be the number of pounds of New York strip steak, and then R is going to be the number of pounds of ribeye that you buy. So from there, we can write our inequality. What does it give us to write our inequality? Well, again, we know it's $9 per pound for a New York strip, so 9 times S plus 12 times R, the pounds that you buy for a ribeye. That's going to be how much money you spent at the supermarket. And that all has to be less than the total of $120 that you brought to the store. So we say 9 times S plus 12 times R has to be less than or equal to $120. Perfect. Now we need to create our graph. In this instance, it doesn't matter which one we consider our X and which one we consider our Y because they're both just pounds of steak. There is no dependent or independent variable. So it doesn't matter which one you put on which axis here. I'm going to just put the New York strip on my X and the ribeye on my Y. Now, let's go ahead and graph this guy. So how do I graph this? First, we need to put it in slope-intercept form. Well, if R is going to be our Y, I need to get Y by itself, right? It's got to be Y equals mx plus b. So to get R by itself, I need to get this 9s to the other side. So I subtract both sides by 9s. These cancel out. And then over here, when I write this, I could write 120 minus 9s. But again, I want it in slope-intercept form. I want mx plus b or ms plus b in this case. So I'm going to put this term first and then add the 120 to it. So it looks something like this. Now, to get R by itself, I divide both sides by 12. These cancel each other out. Negative 9 over 12. That's going to simplify to, if I divide both of those by 3, negative 3 over 4 times s. And then 120 divided by 12 gives you 10. Now I have it in slope-intercept form, so we can plot 3 points. Since there's an equal sign here, we can shade in those 3 points also. So what is our y-intercept? That is going to be 10. So at 0, 10, I'm going to put a point. And then the slope is negative 3/4. So I'm going to go down 1, 2, 3, right 1, 2, 3, 4. Put a point. Down 1, 2, 3, right 1, 2, 3, 4, and put a point. Now I have my 3 points. I decide, is it a solid or dashed line I'm going to draw through there? There's an equal sign here, so I draw a solid line going through those 3 points. Next, do I shade above or below this given line? Well, r is less than or equal to. That means it's facing away from my r or my y. So I'm going to shade below the given line because I want all r's less than or equal to this given expression over here. Now, I have successfully graphed my given inequalities, so that's done. I also need to name 3 possible amounts of each stake you could purchase. Remember we talked about the solution to this inequality could be any point in this given region, or since there's an equal sign here, on this given line. So we just pick 3 points in the region or on the line, and that would make this true. So let's look. I picked that 4 pounds of New York strip and 7 pounds of ribeye would work. 4, 7. Yeah, that's on the line, so that works. What about 5 pounds of New York strip and 4 pounds of ribeye? So 5, 4. Yeah, that's in the region. That would work. And then 7, 1. 7, 1. Yeah, that would also work. That would all be less than the $120 I brought, so it would all work out. Perfect.